The lesson topic for this video is graphing radical functions, cube roots. So this is going to be similar to the previous lesson about square roots, but now we are talking about a cube root. So what this means is what number, when multiplied by itself 3 times, is x. So we're going to start just like in the previous lesson by using a table. All right, we're going to do f of 0, which is the cube root of 0. So what number times itself 3 times is 0? Well, that's obviously 0. Then we're going to take f of 1, which means the cube root of 1. What number times itself 3 times is 1? Well, that's 1, because 1 times 1 times 1 is 1. F of 8 is the cube root of 8. What number times itself 3 times is 8? Well, that would be 2, because 2 times 2 times 2 is 8. And now we're going to put in a negative value just like we did with square roots. We're going to say f of negative 1 equals the cube root of negative 1. So what will that be? Well, what number times itself 3 times is negative 1? Well, this is different than with square roots. With square roots, we could not take the square root of negative 1. We'd be in the imaginary number system. But this time we can, because negative 1 times negative 1 times negative 1 is negative 1. So there is a cube root of negative 1. And if you check that on your calendar, you'll see that the cube root of negative 1 is negative 1. The same thing happens when we do f of negative 8. Again, what is the cube root of negative 8? Well, what number times itself 3 times is negative 8? Well, the answer there is negative 2. And again, to think about this, we think about what's negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. Okay. So if we plot these points, we'll see what a cube root function will look like. 0, 0 is right here. 1, 1 is right here. 8, 2 is right here. Negative 1 is right here. And negative 8, negative 2 is here. So what we have is, again, what looks like a half of a parabola on its side off to the right, and a half of a parabola off to the left, and going down like that. That is what the parent function for a cube root function is. What this tells us is that for cube roots, we are either going to have a curve that goes up and to the right and down and to the left, for the full curve, or down and to the right and up and to the left to make a curve that looks like this. And that's what they'll look like. Let's try some. Okay, so now we'll look at how a transformation of that cube root parent function will look. And what we're going to use here is similar shortcuts as we used for square root functions. We're going to look at the sign of the a value and the sign in front of the x, and we're going to use the h and the k value just like we did with square roots, but with just a couple of minor differences. Okay, so first of all, remember that with square roots, it curved up and right, or up and left, or down and right, or down and left. But now with cube roots, it's either going to be this smooth curve that goes like this, which is increasing from left to right, so it's lower and it's getting higher on the y value, so it's increasing from left to right, or it's going to be decreasing from left to right. Okay, so how do we determine if it's increasing or decreasing? Well, to do that, we are going to pay attention to whether the signs in front of a and in front of x are the same or different. If they are the same sign, if they're both positive or both negative, it's going to be an increasing function. But if they're different, it's going to be decreasing. Then we have the h and k values just like we did for square root functions, and h and k are determined the same way, and now we just call that an inflection point instead of a starting point, because it's just the point where the curve changes direction a little bit. Okay, so let's take a look at this example. First of all, notice that the a is negative and the sign in front of x is positive. Since these are different, it's decreasing. Let's try that again. Decreasing. Because they are different signs. All right, and then h and k. Again, you'll need to rewrite it. If the x was negative here, we'd rewrite it, but it's not, so we take the opposite of what we would think here, so not -3, but +3, and exactly what we would think here, so +7. All right, so we're going to plot the point at 3, 7 for our inflection point. 3, 7 is right here. And then we are going to curve in a decreasing fashion. So from left to right, it needs to be decreasing. So it needs to be going down like this. That's decreasing. And then therefore it's going up and left this way. So again, notice what we have is the inflection point right here means it's changing direction at that point. So right now, it's curving this way, and then it straightens up just a little bit here, and then it curves back this way here. What you'll also notice is that what you have on the left-hand side of this inflection point is a half of a parabola opening on its side, and what you have on the right-hand side of this is a half of a parabola opening on its side too. So again, it looks parabolic on its side. Okay, so let's try a couple more examples. Okay, this first one, we're going to look at the sign in front of each of the a and the x. They are both positive. There's no negative signs. So since they're the same, it's going to be increasing. And then we're going to write our h and k values as they are needed here. So the +4 means that we have a -4 for an x value, and then a -8 will stay the same, -8 for our k value. So let's plot -4, -8. That point will be right here. And then it's increasing. So it's going to be going up to the right, like this, and then down and left would be going this direction here. Now it's kind of off the graph, but if you wanted to curve it, you could like that. Okay, let's try this next one, and then keep watching this lesson, because on the next page we're going to talk about what happens again when that x value is negative. All right, so this time again we're going to look at the a value is negative, and in front of the x is positive. Since one is negative and one is positive, they're different signs, so it's decreasing. All right, and then our h and our k, well, it's got a -1 in the root, so it's a +1, and then we've got +2 on the outside of the root, so +2 stays +2. 1, 2 is right here, so there's our inflection point, and it's going to be decreasing from left to right. So it's going to be going down and to the right this way, and we'll be going up into the left this way. Okay, I'm going to do one more example with you to remind you what happens when x is negative, and then I'm going to ask that you do this last example on the right on your own by first rewriting it in 2 steps, and then graphing it and checking to see how you did. So this first one, remember, anytime that x has a negative, is negative, we want to factor that out. So you're going to rewrite the equation anytime x is negative. So y equals the cube root of, and now we're going to factor out this negative, x will become positive, and the +3 will become -3 because we're factoring out a negative, -1. Okay, now we will determine what our inflection point is and how it will curve. So again, out here is positive, and right here is negative. If one's positive and one's negative, it is decreasing. If the signs are different, it's decreasing from left to right. Our h and k values, well, in the square root, we've got a negative 3 right here, so it's going to be positive 3. And it's a negative 1 right here, which is going to stay negative 1. So we're going to plot 3, negative 1, which is right here. And now it needs to be decreasing from left to right. So it's got to be going down and to the right here, like half of a parabola opening on its side. And the inflection point changes the direction, and it'll be going like this to the left. Okay, I'm just going to try this out here. If I took this and just covered up half of the curve, you'll notice again that this looks like a half of a parabola on its side. And if I move this and covered this side, you would see again half of a parabola curving on its side there. So you just kind of look at the two different pieces as two different parts of a parabola curving in different directions. Okay? All right, go ahead and try this last one on the right and then check back to see how you did on it. Okay, so you should have rewritten it first by moving the negative x and the positive 7 around, and then rewrite it again after factoring out this negative here. So this is the equation that we're going to work with. Since they're both negative, they match, which means it's increasing, and we've got the opposite of negative 7, so 7 and negative 3. So to graph that, we're going to plot the point 7, negative 3, which is right here. And then it's going to be increasing to the right. So up and to the right here, half of a parabola, and then down and to the left here.